So for our homework, we were to write this function that should called isPrime that takes a number as a parameter, and it should return true if the number is prime and false otherwise. It was brought to my attention there's actually a test in here for primes, apparently. It's fine if you wanted to use that. That's technically you fulfilled the assignment. But we're going to avoid using that at first, just to kind of work on the logic. But where is it? Is it in math somewhere?
It's under round.
It's in this guy?
Sorry, no, it's under is.
Oh, to test if it's prime. I got it. Odd, prime, whole, positive, negative, divisible by. Oh, divisible by is, we might take advantage of that one. Okay. But we'll go ahead and do this the long way because we're going to be kind of segueing towards introducing something called the Euclidean, well, yeah, Euclidean algorithm will do what we need. Okay. So, first of all, if number is, for example, 30, we need to check all the numbers between 2 and 29, right? We know that the number will be evenly divisible by 1. We know that the number will be evenly divisible by itself. So, if it's prime, that means it's only evenly divisible by those two things. So we need to check all the numbers in between those two things. So we'll need a loop that'll go through the numbers 2 through num minus 1. So we'll have our counter here. We'll start at 2, go all the way up to num minus 1. And increment by 1 each time. Each time through, we need to ask the question, is the current number we're looking at, actually, that's for right now, let's just kill this stuff. Is the number we're currently looking at, the value of j, does that evenly divide into num? If it does, this guy's not a prime. Okay, so we're going to ask a question. If, and we can go ahead and use that say is if num is divisible by j. Okay, if num is divisible by j, we can do something. Otherwise, we can do what we did before. We can do, does this guy support modulus? Remainder of. I like that one better. Remainder of num divided by j. If that guy is equal to 0. So when I take num, I divide it by j, and I get the remainder. If the remainder of that is 0, that means that j evenly divides into num, which means that num is not a prime number. Okay? Therefore, if it's not a prime number, I want to return something. All right, well, I need to come up with the value that I'm going to be returning. So I'm going to have to store that somewhere because we don't have our opportunity to return something until down here. Okay, this is kind of like the we talked about with game salad, the matrix that we're having to kind of play inside. That is, in other programming languages, we could have just returned our value right here and said we're done. But Blockly doesn't give us that option. I don't believe, do they? Do they give us an ability to return at any point in our code? We have an if here. It looks like they maybe do. I can say this. Return false. So it looks like we could do it that way. All right. But assuming this didn't exist in the language, like I didn't think it did, let's look at an alternative to it. We'll finish it this way. Well, no, we won't. We'll just look at the alternative. So we'll go back to our normal plain Jane if. So whether this existed or not, we didn't know it existed. So if the remainder is equal to 0, then we'd like to return false. What we're going to have to do here is we're going to have to keep track of the value we intend to return. So we're going to set maybe call it answer. An answer will initially be true, let's say. As far as we know when we first get started, this guy is a prime number. We try to disprove it being prime in this loop. This loop goes through and it tries to determine if there's any reason to think that this guy actually is not prime. Okay? So if we find another number that evenly divides it, then we're going to set answer equal to false. Now, do I need to check any other numbers? So if I'm looking at all the, let's say the number's 50, and I'm looking at all the numbers between 2 and 50 to see if it evenly divides 50. Once I bump into one number that evenly divides, 2 and 49 rather, once I hit one number that evenly divides 50, do I need to check any additional ones, or is this guy already not prime? As soon as if I find even one number that evenly divides the number other than 1 in itself, it's not a prime number. I don't have to check any more numbers. I could go through the motion and check the rest of these numbers. Whether I find another one or 20 other ones, doesn't matter. The guy's still not prime. I only had to find one. Okay, so since I only had to find one and we want to try to be somewhat efficient, I need to get out of this loop. I've gone through the loop. Maybe I potentially could have gone through the loop 100 times, but let's say I've only gone through 4 times. I found the number that makes it not prime. Therefore, I set it to false. But now I'd like to break out of this loop. I need to get out of this loop. Using only what we've done in class so far, how could I get out of this loop? Because I assume somewhere in there's a break. Yeah. Which is all fine and dandy. Break's going to do something good for us, and we're going to end up using break. But if we don't know that break exists, using only what we've done up to this point, playing MacGyver, how can we get out of this loop? Print? How does
change J's value?
Change J's value. So this loop keeps going until what happens? Until J finally reaches num minus 1. Well, so could I just change J's value to num, for example? Well, we're going to fail this Boolean expression the very next time through, right? So if I go into variable and I set J equal to num, that means the next time through this loop, we'll fail this Boolean expression and we'll be done. So we'll fall right past it. And then what we're going to do is we're going to return our final answer. So answer starts off as true. We test potentially all the values between 2 and num. If any one of them breaks the rules of being prime, we change answer to false. And then we get out of the loop. All right. One way or another, we finally get to this point of the program right here. after the loop is done. And we're just going to return the current value of answer, which is either our original value, true, or the modified value, false, if we happen to get inside this if statement. Make sense? Okay. So then we can test this. And let's test it against the number 5. So 5 is a prime number, so this should give us a true. We test it against a 6, not a prime. This should give us a false, so on and so forth. Okay. So we have a couple of, to kind of, I guess, flesh this out a little bit more. I assume in loops, oh, here we go, break out of loop. So instead of this guy right here, this will just get us out of the loop. So there's our break out of loop. There's also going to be a continue in here. So these are two constructs that are in modern programming languages. One of them gets us out of the loop entirely. The other one just says skip this iteration of the loop and move on to the next one. That's what continue does. Okay? And then similarly, we had the this whole if thing here. We could have modified that to, instead of using the remainder, we had the is divisible by, right? Is that in math? So if num is divisible by j, if that's a true statement, so that replaced checking to see if the remainder is 0, then do this. We'll get the same outputs. It's false for 6, true for 5. Okay, similarly, we didn't even have to deal with this variable called answer here if we didn't want. We could have used that. Is it under functions? We could have used this version of the if, asked this question, and returned false. If something was a problem, which actually then means that we don't even have to break out of the loop, because return makes a function immediately end. So now I don't even have to get out of this loop. I can just check, and if I found even one value that breaks it, return false. Okay, so again, this should give us the same result. Row. If num is divisible by j, return false. Oh, I never, answer has, this guy is a prime number, so it never got here. It tried to return the value of answer, which didn't have a value. Some point we need to be able to return true. So there's our true for 5, and our false for 6. Okay. Similarly, we could have avoided even having the loop using the built-in function. False for 6. True for 5. So I suppose your homework could have been as easy as this, but that wasn't what I intended. Wasn't what I intended. All right. Questions about that? Okay, so I guess my intention is for all of these things for you to always solve the problem in terms of what we've introduced in class, because we're trying to drill the logic aspect of this, and because that's just going to help you next semester when you're starting to rate actual syntax in Java. But it's good that you have built-in functions. You can figure out how to use them, so that's not the end of the world. Okay. So now we want to get a little bit more complex. Let's say we take in a string that looks like 25 plus 4. Okay, we're going to take in a string that looks like that, 25 plus 4. We wanted to return 29. Okay? It's going to take in a string in this format, and for right now, we're just going to have a left operator and a left operand and a right operand with an operator in the middle. So our string will always be in the format of operand, operand. Okay? And we're going to go ahead and allow as many spaces in here as we want. So they can put spaces in there if they want, so the white space is ignored. All right? So we want to write a function that takes a string in this format in, figures out the math it needs to do, and outputs something like this. Okay? So in order to solve this problem, what are the steps I'm going to have to take? So we need to start thinking about these baby steps as we keep limping into these problems that are more and more complex. This will be the most complex problem we've solved so far with Blockly. What are the steps I'm going to have to accomplish? Go ahead.
Create 2 variables.
Okay, well, possibly. Why am I creating 2 variables?
One for each operand, and then using one of the math operations for the op.
Okay, so before going too much deeper, you're saying we need to figure out what the first operand is, we need to figure out what the second operand is, and we need to figure out what the operator is. Once we know those 3 pieces of the puzzle, we can go and start doing some math, right? Okay, so just for starters, let's try to figure out what the first operand is. That means everything up to either a space or an operator. Does that make sense? All right, so we're just going to try to capture just that very first operand as a proof of concept. So we'll go back into Blockly. Did I delete everything or did it delete everything? All right, good. At some point, I'm going to go in there and modify this and put a save button. This is what came from Google. It shouldn't be that hard to put a save button and just have it right to the cloud somewhere. How many of you in doing your homework have accidentally deleted everything more than 50 times? So copy the XML often. I guess it's just the nature of the beast, but I wanted to make sure. I mean, I'm liking this tool so far. You guys think it's pretty cool? I think really this is far more applicable to what you're going to be dealing with next semester than Game Salad. And Game Salad is. So I'll definitely beef this up a little bit in terms of giving some save things and maybe a login so you can go back in and go back through your old solutions and save stuff. Okay, that would be helpful type things. All right. Out of curiosity, anybody going to be here over summer looking for maybe an internship or something? Programming? Possibly? Oh, no.
Sorry.
No. Not for programming? Because we can maybe turn this into a little internship to update this. Be a good learning experience. Okay, so in any case, let's start off we're going to want to create a function. And we're going to call this guy doMath. Okay, and this guy is going to take a single input. We'll call this guy the formula. All right, so that's our math formula we're going to take in. Okay, and let me just do something here real quick, because I think there's been several people have been asking questions that maybe show some misunderstanding here. I'm going to print out formula. So as of right now, this is a function called doMath that takes a single parameter in called formula, and all it's going to do is print out what it received. Okay, I'm going to come down here, I'm going to call this guy a couple times. (25 plus 7), we'll call the first time. And then let's do 13, actually let's do, well, we'll do a couple of these. 13, bunch of plus signs, minus, couple plus signs, 4. Something like that. I wrote my function once. Remember, functions are reusable chunks of code that we can call multiple times. We write it once and use it over and over again. So I wrote it once, and this guy takes in some input that we're going to call formula here. So anytime inside of this function, when we say formula, we're talking about whatever was passed in. Okay? Now, I'm calling my function 2 separate times. The first time I'm passing it this guy. The second time I'm passing it this guy. So this is going to print out 2 separate values. The first time through, it's going to print out 25 plus 7. Second time through, it's going to print out 13 minus 4. Proving that we are sending this in as an input to this formula, or to this function, and then we're printing out whatever this function received. Okay? Fairly often I'm seeing questions. There's the 25 plus 7, and then there's our 13 minus 4, proving that we had one function that received multiple inputs, as we called it more than one time. Okay? I've seen a lot of folks hard coding stuff inside of their function, just like assuming they're going to do something 4 times or do something 7 times. For like as an example with our prime assignment, prime number assignment, you know, they would just say, oh, I'm testing for 4 being the prime number. So rather than actually passing it a 4 down here, they would just go in and change their code in their function to have 4 hard coded in there. That makes sense? So kind of you know, hopefully this maybe clarifies that a little bit, that the idea of a function is to write it generically. So whatever we're doing up here is done in terms of whatever this guy ends up being when this is running. And this guy, formula in this case, can end up being all sorts of different, all sorts of different things. Okay? Any questions on that? An important concept. Okay, so our goal here is we want to take something that looks like this, and we want to go and extract just this piece from it. Okay? Now we're going to say we're going to ignore white space. Actually, let's start off with the easy case. So it looks like this. Okay? So the very first thing I'm going to do, we're going to assume there's no spaces in our inputs for right now. We are looking at what we have to do if we get a string that looks like this as our input to get the 25. And then all we're going to do is we're going to return that 25. Okay? Actually, in this case, I guess we're printing the 25 since I didn't give us a return statement. We can fix that. Do math. Formula. Okay, so now formula is going to be some string, and it's going to be a string that happens to be in this format, looking like this. That's an operator, followed by an op, followed by an operand. No spaces. Okay, and we're going to initially support, let's just initially support plus signs, just to keep this as simple as possible. Okay, so we know we're at the end of our first operand as soon as we bump into a plus sign. Okay, so we need to go through and we need to walk our string formula one character at a time. So it's going to be a loop. Okay, so we can say for each item in a list, but we happen to have a string. Can we build a string or turn a string into a list? Potentially. Okay, but we could say count is equal to 1. Keep going until we hit the length of our string formula, increment by 1. So we're going to go through a loop starting at the beginning of our string all the way to the end of our string, adding 1 each time, and we're going to look at the character. Okay? Now you mentioned we're probably going to need a variable to store our operand. So let's go ahead and give ourselves a new variable. Let's just call this guy left. Well, actually, let's call it left op. Okay, and left op is going to start off as the empty string. And as long as we don't hit a plus sign, we're going to store our left op in this string. So we're going to append it one character at a time. Remember, in text, we have a append text function. Okay, so before we can use that, we need to ask the question. The question we want to ask is, if we are not looking at a plus sign, then we're going to append. So how do we ask if we're not looking at a plus sign? Using what I have here so far. I want to ask the question, if the current, here I'll give us a string here. Ask, is the current character we are looking at a plus sign? How would we ask that question in the context of this code? Well, baby steps. How do I access the current character of my string? I want character I of my string. So the first time through, that'll be character 1, then character 2, then character 3, then character 4.
A random integer?
Why would it be a random integer? I is the actual position we want, isn't it? So we're looking for something in formula, and we're looking at letter I. So maybe for right now, let's just print that. Let's prove that we're getting there. Well, let me run this without returning. Oh, I have to call it in the first place, but potentially it still will. So we're going to do math. We'll pass it. 25 plus 3. And we're hoping that we get 2, then 5, then plus, then 3 printed out, proving that we are able to access each individual bucket of our string. There's the 2, there's the 5, there's the plus, there's the 3. Okay? I want to keep reading stuff until I finally hit a plus sign. So how do I ask if I've hit a plus sign? Well, how do I ask any question? With an if. Right off the bat, if you're asking a question, you need an if. Drop it in there. And what's the question I'm interested in? Well, it's going to involve the current character we're looking at. Specifically, it's going to involve some logic. The logic is going to be, if the current character I'm looking at is equal to a plus sign, I want to do nothing. But if it's not equal to a plus sign, I want to build up my left op, which means I need to concatenate stuff onto left op. So I'll come into text. We're going to append some stuff. We're going to append it to left op. What are we going to append? We're going to append the current character we're looking at that was not a plus sign. Okay? In the end, we're going to go ahead and we're going to return left op. Okay, so all this code does, well, actually we need to do this as well. So then loop the break, yep. Just throw it else in here. Every time through the loop, if we're looking at something that's not a plus sign, tap it, go ahead and tag it onto the end of left op. If we do finally hit a plus sign, for right now, we're just going to break out of our loop. And then in the end, we're going to return left op. So this should only capture everything up to, but not including the plus sign. Make sense? Okay. And then we'll go ahead and print out whatever this returns. So our hope is this gives us a 25. And there's our 25. Okay, so we were able to extract that first number. Similarly, if I call this a second time, and I pass it 387, the first time it'll print out a 25, second time it should print out 387. Okay, two separate calls, they each get their own copy of those variables. So we start over with the variables. Okay, so this guy right here reads the left op. Now the next thing I need to do is I need to actually get the op, correct? Well, we know when we are in this else here, just remove this for a second, we know when we're in this else that we're actually dealing with bucket I is where our operator is. Okay. Right now we're saying we're only supporting plus signs. So we're going to have another variable here. It's going to be interesting. If I rename this, will it rename the other one? I think so. So we're going to create a new variable, and we're going to call this guy just op. Okay. And just for the sake of, well, here, we know op is always going to be the plus sign. Okay, now, if we are in this code right here, we know that op actually lives, that plus sign we found, lives at position I. That's where it was. I need to remember where op was. Why do I need to remember where I found op? If we're looking at our code here, my code looks like this. So I added this to left op, added this to left op. Then I found the plus sign. So this is at position 3, right? Why do I need to remember that position 3? Because the next thing I'm going to be doing is reading in my second, my right operand. I need to, go ahead. Not only does it, yes, it does separate them, but where am I going to start reading my right operand at? Position of op plus 1. correct? I need to know that I'm going to read my right operand after this guy. Make sense? So I'm going to create even another variable up here. Actually, for right now, let's actually just call this guy, let's just rename it. We'll call this guy oppause. Okay, and oppause is actually going to be a number. We don't need to store our operator because we know it's always going to be a plus sign right now. Okay, so we'll start oppause off at 0 for right now. We know we're going to set it in here. So before we break out, we need to set oppause equal to I. That's where our operator lived. Make sense? Okay. So this first loop read our right operand, or left operand. Now we need to read in our right operand. Create a new variable called right op. We'll start that off at the empty string. We'll have another loop. Actually, I need to steal the whole loop. Well, another loop right after this guy. And this loop is going to start off at oppause plus 1. So start off at oppause plus 1, go all the way to the end of formula. Okay? So this will get our right operand. Add 1 to it. Now, do we need to look for a plus sign? If I'm right here, and I started at this position right here, when am I at the end of my string? When I hit the length of my string. Doesn't this loop that we have already go that far? This guy goes to the end of our string, as is. I don't have to ask this question. Instead, all I have to do is keep appending text from my formula onto right op. And then in the end, we can go ahead and return right op and prove that this worked. So we're building up left op now, but we're never doing anything with it. And now we're just going to prove that we can get the right-hand side of this. So we'll get the 3 in that case, and we'll get the 221 in that case. Proving we can get everything after that. There's the 3, and there's the 221. So we got our right operand. Okay, well now, after these 2 loops, we have our left operand, we have our right operand, and we know what the operator is. The operator is a plus sign. Okay, because that's the only operator we're supporting right now. Okay, now we want to do some math with that. So let's get our math formula here. We know it's going to be a plus sign. We know we want to do left op plus right op. And return that. So this should give us a 28. And this should give us whatever those numbers added together is. 387 plus 221, 608. $253. What did it do? It concatenated them. Because the plus sign in JavaScript glues things together, concatenates. Because this guy was a string. This guy was a string. I actually want to add them. How do I turn strings into numbers? What do you think? Is there anything built in that we know of that you could just convert a string to a number?
Text list. Create text with.
Well, it's still going to give us that create text with generates a string that builds a string.
Put into a list.
Okay, put it into a list. What's that going to help us do? So you want to put it into a list and then take it out of the list, hoping that it comes out as a number?
Yeah.
Okay. Well, we could try it.
I don't think it's gonna work.
Okay, so let's go ahead and let's go into lists. So we're going to, let's go ahead and create a variable. So we'll set LST equal to create list with, and we want to create it with left op and right op. Take this third item away. All right, so we have our two ops in there. And then you want to do the math by taking things out of our list. So you want to say in list, get element 0. And in list, get element 1. Well, let's see.
The element 1 and 2, right?
Oh, 1 and 2, thank you. Most programming languages starts at 0. So remember that next semester when we do Java. We still have 0 somewhere. Just in case. It's a lot of code here.
We're pulling it out of list. You need to get it out of LST.
Oh, thank you. Oh, no. Oh, yeah. Thank you. Thank you. Yeah, I had the generic list here that came with the in list. We set our list to LST. Not read property 1. In LST, get number 1. Oh. There we go. See, I was testing you multiple times in this thing. Okay. 253. Same problem. So they went in as strings. They came out as strings. All right, back to the drawing board. I need left op and right op to be numbers. We're going to write a function. called string to int. And this guy is going to take in a string s. And he should return the integer version of s. Okay? So for our homework, we want to write this function. Now I'm going to give you some hints. Let's say, here, I'll just do a new slide real quick. String to int. So this guy might take in the string 25. And we wanted to get the number 25 out of that. Make sense? All right. We've done this before. This is the ones place. This is the tens place. So 5 times 1 plus 2 times 10 is equal to 25. So this is convert base to decimal. Make sense? All right. So go back, look at your notes, look at your past homework. To convert a decimal number that's in string format to its equivalent numeric number, we'll use the same logic as we did in base to decimal. All right, I'll put the XML up. I will see everybody on Friday.